So
there's another thing, right? So there's the money, right? But then there's the so there's an economic imperative about this. But then there's another one, is that whenever we ask people, do you love working with legacy systems?
Oh, yeah.
Right? Nobody says yes, right? Nobody says yes. And that's like a terrible thing. Now think about this. Let's put it in perspective. So we went through a major, social disruption over the last year with the pandemic. But we as developers, we could continue producing value, being safe, while everybody else was dramatically impacted.
Right.
Right. That's how privilege looks like.
In this edition of the Data Nerd Herd, I had a great chat with Tudor Girba. He is the CEO and co-founder of Think. He's also a software environmentalist, and he also works on the Glamorous Toolkit project. As you'll see in this interview, the common thread with Tudor is to help developers have a better experience, make code more readable, and improve the time to value for delivering software. We also discuss his concepts of moldable development and analysis. This is a very fascinating and deep diving conversation. It pushed me in a lot of ways I hadn't really ever thought of with respect to software engineering and writing code. So I hope you also learned something from this discussion. With that, let's get going. Hey, Tudor, how's it going?
Hi, nice to meet you. Thanks.
Nice to meet you. Yeah.
I'm fine. How are you?
Awesome. Good. So today on the Data Nerd Herd, we have Tudor Girba. For people who don't know who you are, do you want to give a quick intro?
Yeah, so I'm the CEO of Think. At Think, we are focused on making the inside of software systems explainable. And to this end, we created a new way of programming that we call moldable development. And we are also building a new kind of a development environment that is called Glamorous Toolkit.
Interesting. I mean, what problems are you trying to solve with that?
Right. So the problem that we started from is the problem of reading code. Right? So if you look at what developers do, for the large majority of time, people don't write code, they read it, right? And they read it with a very specific intent, and that's to figure out what to do next. So it's not, there are situations where you would read, for example, to learn, like when you learn a new language or so. But in most situations, people just want to understand how they could do something. How could they affect the system? So from that perspective, if you look at it, at the act of reading from that perspective, it's actually, reading is just a way in which we gather information out of data to support some sort of decision making. And given that this is the single largest expense we have, we think, well, we better make it, better this activity would be efficient. And reading happens to be the most manual possible way to extract information out of data. So, and then here we are talking about, data in general, right? And by now we know that there are many other ways in which we can extract information out of data, and without ever seeing the data. That's the interesting thing. In fact, most systems in the world today, they do exactly that. They take data, manipulate data, aggregate data, visualize data in a way that makes humans make decisions faster and about an ever increasing amount of data. But they specifically prevent the users from ever seeing the raw data. And the interesting thing here is that we as developers, we have this magic ability of transforming data problems into decision-making problems. But when we have our own problems, what do? We fall back to the most manual possible way of doing things. And I think that has to change. And that's what moldable development is. That's where it started from.
Interesting. I mean, what were some of the insights that you had to come to this realization? I think everyone talks about, code should be readable, but I think you're taking it a bit of a different level of thinking.
Indeed, we challenge the reading part, right? And that's the insight came once I come from research, and my area was software analysis, software evolution, looking at software repositories, looking at history, dynamic analysis. And the goal there was always, build tools that support developers. And then at some point, I was writing a paper, and a lot of the motivation about those kinds of papers is this idea that developers spend more than 50% of their time reading code, right? And when you're 50% or more, that means that's a single logic expense, right? There's nothing larger than that. So that's kind of like an interesting thing to spend your time on, because any improvement there will have a significant overall effect. But then I realized that the oldest reference on the topic that I know of dates back to 1979. And then I was thinking, so what did we do for decades? I mean, if we still have exactly the same problem in exactly the same way, is it possible that maybe we looked at the problem in the wrong way? And so that was the way we. And so then we basically started to ask this question more systematically, and then we worked backwards. So what if systems would be understandable in a very short amount of time? What if you could compress the amount of time it takes for you to answer a question about a system? And that's another thing. When people think about readable code or so, they just imagine, for example, in the context of explainable AI or understanding, data pipelines. Those are very important topics today. But what if, and people think of it like, oh, what if we can make the code look better in general, right? So understandability would be it's like a generic property of the code. But then when we look at systems, we see, well, there is no, all systems, they look similar, but they are really, really distinct. It's kind of like the same as with data science, with data problems. Like if you look at the history of data science, right, it started from simple reports, dashboards, but those dashboards were all kind of hard-coded, right, with very little things that you could tweak. And now what do we have today? Well, today you're saying, well, there's a skill of transforming data into information that you want to make decisions on. So we start from the problem, and then we build the tool. And that's the interesting thing, right? That's the revolution that happened in data science. And that's exactly what has to happen in software development as well, because every single development problem contains a tiny data science problem. And any problem we have about a system is simply just a navigation of that data, and you can summarize it in a narrative about the data. And that's pretty much it. That's how it should be. And then, of course, the question is, how should it be embodied, right? How should the technology look like? That's a whole nother thing. But the first problem we should realize is that we have a problem. So if you look, for example, in the data science space, or even in the software engineering space, before people started to talk about deployment, the systems, the kinds of businesses that are possible today were hardly imaginable a decade ago, right? The kinds of systems that you have, you can build with data today were difficult to imagine just a decade ago, for example. And
what are some examples of that?
Well, I mean, just having a company that sells compute
Mm-hmm.
And have you deploy your app in 5 minutes. That was not imaginable. It was difficult to imagine. Like if you would squint very hard, you could kind of see it, but you'd have to squint very hard and look exactly in the right place to see it. So it was not obvious, right? It's still not obvious for many people today. But there are whole business models that are possible today that were not imaginable before. So What made that possible? The subject conversation. we said, well, this is an important subject of conversation. And once we started to talk about it, there's a whole evolution that just things evolve very, very rapidly. And just, we are in a completely different world today because we had that conversation. When it comes about software and how we reason about software, nobody talks about it. Like the way you read code is never a subject of conversation. And I think that has to change.
Let me take a step back here. I mean, what does readable code mean and what does it look like?
So I think all code is readable because it should be read by machines and not by us. And so if you think about, let me give you an example. So I'm gonna share the screen here.
Oh yeah, let me get that in there. Yeah, go for it.
So I'm sharing the screen, and what you're seeing here is Glamourous Toolkit. So Glamourous Toolkit is a technology, is an environment. It's free and open source, and it's a self-contained. You can download it and play with it. It's a self-contained system that is built on top of a Smalltalk environment as the base language, but that's not particularly relevant. So, and for example, here we have a bunch of notebooks that are linked. That's also not particularly interesting. So let's say a simple problem, like a super simple problem. So for example, here I am looking at a system, which is actually just a small mobile application, a React Native application. And I can see, things like source and, like what you would expect to see from an inspector from, looking at the file system, right? But this thing that I'm seeing here, this is actually not the files, not a tool for browsing files. This is actually just an object. So it's an inspector open on an object. So in this case, this is a file reference. And as a consequence, I can see it like this. But, what do we mean by an inspector? Every time you put a breakpoint somewhere in the debugger, right, you see these kinds of, variables and values. Right? That's the typical inspector, variables and values, right? And then in our case, we're saying, well, and if you think about like how is an inspector defined? An inspector is defined as being a tool that shows you the inside of an object, right? The structure of an object. And then so like, but that's usually not that interesting. It's much more interesting to say, well, how would I consume this object? So this is a file referencing pointing to a folder. This is a much more interesting view, right? The way this one is implemented inside is maybe interesting for some people, but in very rare occasions, like in the vast majority of cases, it's much more interesting to look at it like this. All of a sudden, there isn't just a single perspective to look at, even at a single object, like one tiny object, one object in the system. You don't have a single perspective, and that's the core of Moldable development. So we're saying that software is super contextual, and because it's so contextual, we can't predict specific problems people will encounter. We can predict classes of problems people will encounter. And as a consequence, we can't give them clicking tools because any clicking tool bakes the problem in the click. Right? If I give you a button to run this, the meaning of the run is baked in that button. And so, and solves whoever problem create, like whatever problem people that created the button had. While I would like the environment to be what I'm interested in. So we actually can create these kinds of views anytime we want. But so let's go back to our little problem. So here we have, for example, this is a package.json, right? So again, nothing really major. But if I look at this, it's also a file reference, but all of a sudden this one gives me a JSON file here. Okay, so it's kind of maybe more interesting. I can see here, this is an editor that I have. But so let's take a simple problem. So here I have dependencies. I have dependencies from this folder to whatever other things there are, right? So I can see there are dependencies to React Native. So okay, yeah, that's a React Native application. So let's say I want to reason about dependencies. The first thing I need to do is list all those dependencies, but I'm not interested in the React Native application, like in the dependencies to React Native, because that's the framework. So the question here is, how would we find the dependencies that are not going to React Native? It's such a simple question, right? It just even fits on a screen. So talking about readable code, is this readable? Yeah, it's kind of readable, right? I can see this is JSON, right? It's here, this is the key, this is the value. It's kind of understandable from that perspective. But now I don't want to read it. I just don't want to see this, right? That's it. It's a simple problem. So how do I do it? Well, it's kind of difficult here in an editor, right? Maybe I don't know how do I search for things like that. But then on the other hand, this is not a piece of text. This is JSON, which means it is superstructured data, right? So because it's superstructured data, I can take here a playground. So this is like a notebook applied for this context. So here self contents, if I say self is going to be this file reference, I can send a message to it. So self contents, if I execute that, it's going to give me the string. So now this is a string. And of course, because I already have a JSON parser, I can say, give me parse this. And when I'm parsing this, so this is like a little piece of script here. I can take a look inside if I want to. And so if I execute this, what do I get? Well, I get a dictionary. Now, a dictionary is much more interesting because look, I can take a look here and I can see those, right? So I can, if I now query this and I say, well, add dependencies, and I do this, then I get a dictionary, which is the inside of the dependency, right? So actually, I just want those to see as key values. So now I have an array of these, right? And now I can just select those, for example, for which the key begins with React Native. And so now I have all the dependencies go to the React Native. So if I'm not interested in those, I can just reject them from here, and now I have this. So that's the flow, right? I had a question, and then I realized I don't have an appropriate tool for it. So because I didn't have an appropriate tool, I wrote a little tool. I built a tiny one. And now all of a sudden, my environment just became something with which I query, right? So I was browsing, kind of like a passive thing, and then it became an active thing. And so that's the idea. The idea is that the environment should always mold to empower me to answer the questions that I'm interested to answer. And when the environment is not offering me what is possible, it should give me the primitives with which I can quickly put a concrete tool together. And then I can manipulate whatever I'm seeing in front of me. It's basically like a transformation, if you think. And then, of course, here I'm applying it to software, but or something that appears to be software, but it can equally well be applied to other types of input. It can be data, it can be APIs, it can be languages, different kinds of languages. So, for example, as I said, this is a React Native application. So I can I can even take a look at one of these. So let's say if I take a button here, and I'll say, well, let's say I want to reason about this one now. So then I'll say, well, this is a JX6 here. You can see here, that's kind of the language. So let's parse this one. And all of a sudden now I get here an abstract syntax tree. And if I zoom into it, I get the source code over here, and this is the abstract syntax tree over there. So now I can start to build tools. If I want to build tools that query the code, it's much easier to build those kinds of queries if you're actually seeing what are you going to query. And that's it, right? So all these kinds of analysis that appear to be magic, and they usually come in black boxes, and people don't know how to do it. And that's mostly because they've never seen how this one is done. It's actually not difficult. It's actually very, very easy. Well, maybe not very, very easy, but it's much easier if you're seeing what you have in front of you. So then you can go a step further, right? And then you can build here. So this is a model of the system. So I parsed it and I built a little bit of a complicated model. And then I can see here dependencies, for example, between components. But these dependencies, these are at the level of JS6, not at the level of the JavaScript, right? So if you're looking at the React application, and if you're just reading JavaScript, right? What is readable code? If you're reading a React code without understanding React semantics, you're missing everything. It's just useless, right? If you're looking at a data pipeline made out of different JSONs for different settings, but you don't understand the framework behind it, you're missing the whole point. You can't read it, right? So that's the problem, right? You have to make, but if you can make the tool aware of the underlying semantics, then all of a sudden the way you're doing things with it is much more interesting. So for example, here, if I click on render button, this is not the end of the conversation, by the way. So any visualization is just a begin, like it's a step into the next kind of, the next level, right? So I can see, so this is a function. I can look at properties of this component, but I can also see the source code of it. So I can see, for example, render button is returning a button, right? That's why I have these comment dependencies over here. So like this, and this is how we're piecing together, like we are, a lot of our, for example, Think, that's the company I'm a CEO of. At Think, we fund ourselves through consulting, and we kind of work with companies that either are in some sort of urgent need, maybe they tried whatever was possible or whatever they knew before with the legacy system, and then they don't know what else to do. And so then sometimes we just need to go in, and then within a few weeks or so a short period of time, or reasonably short period of time, we have to go and understand what's in there, often in a situation where nobody else understands what's in there. And and that's not right. And people are very afraid of that. And we talk about clean code, we talk about technical debt, but all of those conversations are had from a perspective from which, if you already have technical debt, there is no way out. Like it's already too late, and it's never too late. It's like if you change the way you deal with this, we can bring the cost of reading or this decision making to way lower. We think without a larger investment, you can improve it with an order of magnitude. And this is the single largest expense we have in development. So that's one kind of thing. But some other kinds of projects that we are having are related to figuring out data. So reverse engineering data. For example, we recently did worked on reverse engineering, formats that different social medias offer to individuals, and learning things from the data that you have in there. So imagine you have a Facebook account and you're downloading your data, and maybe you have maybe tens or hundreds of megabytes of data, and people don't know what's in there. They don't. It's difficult to see if you're just reading. It's readable. It's also compliant to the law, but nobody can make any decisions based on that. Nobody can learn anything based on that, because it's just in the end, it's still obfuscated. So without an appropriate tool that will allow you to browse that data, then it becomes difficult. So, but then the question is, of course, you don't have the schema for that data. So the question is, what's in there? And it turns out that you can apply exactly the same kinds of principles that I'm showing you here, right? I started without understanding much, and then just crawling up. And you just build these kinds of tools quickly. And if you do it very, very quickly, the way you learn is significantly enhanced.
That's really interesting. Is this available as a like a plugin for any IDEs or Chrome?
No. This is at the moment, this is a desktop application, and it's a standalone application. And the reason it's like this is that you can't fit a square into a round hole. So it's difficult, right? So for example, if I take a typical IDE with an editor in front of me, it's the first thing that people see, right? An editor. If you look at this one here, the editor comes at the very end. It's not the first thing you see, right? And the same kind of thing you want with the data, right? Before you do something with data, you query the data. That's the first thing you start from. And so it's a completely different architecture, basically, or from what a typical tool offers today. So that's the reason why it's not there yet.
Got it. Yeah, I think it's a really cool approach. It's I definitely like this declarative model too, where you're just kind of telling it what you want to see. Yeah, I could definitely. What's been the adoption of Glamourous Toolkit?
So like we have a community, but this is so there's the tool, and then there is the way of thinking. And like if you just people playing with the tool, there's been a number of those. So the first beta release was only a year ago, and but the interesting thing, and that's what we are working on now, is finding ways to teach this. So how do you teach a new thinking? Because that's not it's not based on this. It's probably not the most popular thing because people don't know they need this. They don't know they need something like that. So so that's our current focus.
Interesting. Yeah, I mean, because you brought up an interesting point too. I mean, what would you say the first reference of Readable Code was 1979? You said.
No, not at Readable Code. At the cost of reading.
The cost of reading. Okay, that's good clarification. Why do you think it is that people haven't adopted this more?
It's the way you think. So, for example, I was looking at a couple of presentations looking at data pipelines, right? Thinking just how do you browse things that go from just go through. And so during a 30-minute presentation, I think I saw half a dozen technologies, and each of them coming with a medium, a different medium, right? That doesn't make any sense. It's just that cannot be the way things are. But this is where it leads to when the only thing we can choose from are apps. And every app, comes with, oh, here's my little thing that I'm doing. And it comes also with the data. It's baked into the app. So I'm going to do something here in this app, and then somehow, hopefully, I can get some sort of data, and then I'll do something, and I'll jump into the other app. And so every one of those looks like a special thing. Every one of those looks like a new thing to learn, and that doesn't scale. And then of course people are being overwhelmed by this, and then it's hard to see the forest from the trees. And so what we're doing here with Glamourous Toolkit is also the research side of it. So how do you ask the questions? What kind of questions are interesting here? So that at the end of the day, you go to a different class of solutions. And yeah, so for example, if we just looked at reading code, right? Like the code as a use case, as long as the question you're asking is how do I make my code readable or more readable, you're only going to see code as text, and you're going to look at things that make it readable, which is not a bad thing. It's just not the most interesting thing. And so that's, at the end of the day, what we are interested in is to have that conversation that in a decade from now, we'll be looking back and say, oh, you remember when we were reading code? And then we were looking, here's how we're reading code now.
You have any thoughts on this? I know that when Python was written, one of the intentions was similar, really, where code it was meant to be readable, right? I think the impression that I got from Python was developers spend 70-80% of their time reading code. I think it's what the stat was for Python. Where do you think that it fell short, and why would a Glamourous Toolkit need to complement or replace that intention that Python had? So
Smalltalk is not the first one that tried to make code readable. And by the way, that's a good thing. So at some point you want to read the code. So, like even a small screen or a few amount of lines of code of some obscure language that you don't know about, is going to look difficult to read, right? But if your approach or getting the code to look kind of like something you're maybe more like natural language, like English, then it looks better. It's more approachable, right? So it's easier for people to get into it, to that point. But then if you go to the semantics, right, it's much more interesting if you're forming sentences with your code, because it's easier to read when you actually get to read. The problem with the 70 to 80% of the time is that most of it is searching for the place to read. And it is inappropriate to use reading as a way to find a thing that is worth being read. That's the problem. And especially in a larger code base where things are moving very quickly, then all of a sudden you can't, that's not appropriate. It's not reasonable. And much of the philosophies around code is they also assume that people can form mental models quickly, which is a good intent. But the way we form models is by checking hypotheses. And so the way, if you look at so how do you build a hypothesis? Can I share the screen again? Let me share the screen.
Before.
Right. So I'm going to go back here to Glamourous Toolkit, and there's a book about it, and the book is written in Glamourous Toolkit. And in fact, the whole thing here is just it's a set of notebooks. So it's a book made out of live documents. So here I have a live document that is made out of slides. So I'm now zooming into one of those. So this is just the problem of moldable development. So how do you test a hypothesis? You take a hypothesis, and then you want to apply an analysis, right? And then you get the results, you interpret them. If you're confident, you make a decision. If you're not, you repeat. This is not new. This is the scientific method. But the problem in software is that for your problem, for your specific question, you don't have an analysis. So that's why you have to ask, what is the interesting tool here? Like, I was having this super tiny problem, just listing what are the dependencies that are not going to React Native. It's a simple question, right? And if I look at it through a text editor, it's a difficult question because I have to, it forces me to manually do things. But if I transform it and I say, well, what's the right tool for this? All of a sudden, boom, and it's much cheaper to build. It's much cheaper to answer the same kind of question. Now, if you go further, like the larger kinds of problems that you have, like, we need to split this system into two so that we can scale the second part of it, right? That's made out of little tiny problems exactly like the one we had. And the way you're going to refactor that system is exactly going to be forming those little tiny problems and forming those kinds of questions, each of which would be better served with a dedicated tool. And this will get you in a better place to reason about your system and make decisions about your system. And so this is a fundamentally different departure. It's like it's a complete departure from what we are looking at today. So if you think about, if you compare this with, just take two systems, like take two people and stay 2 meters away from their screen and take a screen, you can't distinguish. You can't say they are working on this system and they are working on another system. I think if I can give you those screenshots of their screens and I shuffle them, you don't know because they look the same. The screenshot will just look the same. You have to squint into the contents to figure out what's in there, right? But here, I don't have to. That's the thing. That's the magic of it. That's basically what we are learning from data as well, like data science. If you change the shape of data, all of a sudden you're in a completely different place, right? And that is that's a really, really large departure. So if we look, at, I was starting from just inspectors, right? So here I have 6 objects, just objects, tiny objects, the tiniest things, in fact, in a system. That's an object, right? So I have 6 objects. If I stay like this, I can't say, is this different than this one? I don't know, right? It's hard, right? I can see, okay, look, this one has more variables than this one, but that's kind of it. right? I don't know anything. But if I change those views to this, boom, I'm in a different place, right? And so, and that's the note. That's basically that's where it all starts. But you have to, we are asking a fundamentally different kind of question. So we are not asking, we're not placing, and by the way, so here's another thing, like people are saying code must be readable, which I'm sure there is, well, not I'm sure, there are ways to, there are objective ways in which a certain piece of code is more readable than another one. But most focus is placed on the code. But then if I take two people and I give them the same, piece of code, one will understand, and one understands it, let's say 10 times faster than the other one, or better in some form, then it must mean that there is some part of this understanding that does not depend on the code. Because if code would be, if the property of understanding code would be just the property of the code, it means that I can give you and I can give it to somebody else, and both of you would equally understand it in the same amount of time and the same kind of quality. But that's not the case. So there must be something that is not about code. And indeed, so there is a translation, the forming of the mental model about whatever we are seeing in front of us. That's an active process. And what we're saying is that, in fact, you never get to see code. You're never digesting code directly. There's always a tool in between. But until now, that tool was always rigid. Like it never changed its shape. The shape of the tool is always the same. And that's a fundamental problem.
Interesting.
If that makes sense.
Yeah, it does. And I was actually just thinking about this. I mean, just thinking about readable code with respect to people who don't code, right? So if you took readable code in its most literal sense, it would be that I could hand my grandmother, who's 91 and has never written a line of code in her entire life, and she should be able to read that and make sense of it, right? And so I think there's, it's an interesting concept where it's, I mean, you're absolutely right. The code itself is sort of inert to some degree, and it requires obviously understanding the syntax of the code, but also understanding the domain to which the code is trying to solve a problem.
Right.
Because, and like I said, in its most literal sense, if code was literally readable in the truest sense of the definition, everyone could read code. Nobody, barely anyone can read code with it, right? Right, exactly. And like, I know most people can't read code, so a lot of people can't read either. In fact,
right. And then we don't even, as I said, like in our the way we earn money, we often talk with people that have systems that have been maybe built in that company for a long time, sometimes decades, and they don't know how that system works. Now that is not reasonable, because we're not talking about lay people. We're not talking about people with no interest. We're talking about people that have a very high interest to do something about the system and cannot. That's the problem, right? That's where you see how, and then of course, so all of this work about making visual programming, getting end user programming, no code kind of thing. They're all fluffy things, but they're all at the surface, and they will all break down, because as soon as you need something from the system you already have, there's no tools. There are no tools for that, because the conversation is not in the right place. Yeah. So everybody today buys systems or solutions from the perspective of how quickly can I build something new.
Right.
But the most important cost goes into, how do I reason about the system I already have? How do I add to that system? And that's the first use case we have to focus on. So if you think about, like development, or, we think about the active part of constructing. That is, you don't have it, you spend the effort, and then you have it. And so because of that, right, the cost of creating a system now is many orders of magnitude smaller than it was a few decades ago, right? Because the cost of a new And as a consequence, the body of software is exponentially growing, or at least superlinearly. So because of that, right? But at the same time, we are unable to recycle old systems. We are unable to change those old systems. So we kind of behave like the plastic industry in that we are literally polluting, right? And that's why my title is also software environmentalism, which is environmentalist, which is a term that I coined, which is about, so we are reshaping this whole world on top of software, but it's the world that we're creating is fundamentally not sustainable, because we're just piling up black boxes on top of black boxes. And that doesn't work. It's just it's broken. So in order to affect that at that scale, right, the question is, what can you do about that? Well, the good thing about software is that it has fractal-like properties. So, which means that kinds of problems that you see at macro scale, you also have them at micro scale. So, which means that if you want to affect large patterns in software, you just have to rethink the tiniest pattern in software. And that's why the largest time in our research we spent in answering a single question: how do I fundamentally change how I reason about a single object? Because the object is the smallest thing in a system. And if I can change that, then I have a chance to affecting the larger pieces. And so that's our motivation. That's how we're looking at.
This would have been really handy at one of my clients. They had this old mainframe from the 80s, and it was programmed by an employee who had worked there for 30 years. He'd started in the 80s and wrote the code. However, he made no documentation ever. Nobody understood the system except for him. And then one day, for several days, he didn't show up to work, and they find out he passed away. And this was the central hub for the entire company, their order system. So, I remember the code. I saw some of it, and I was like, I cannot reason about this if I tried. There's no way at all.
Right. Yeah.
So,
and they are not. And there's, like, for example, there were a couple of events at the beginning of the 2020, the beginning of the pandemic, right? When for example, the unemployment systems in a couple of places in the US got under stress to the point at which the New Jersey governor, I think, came on TV and then said that they need COBOL programmers because the mainframe system is not scaling. Now, there's a lot of politics that probably went into that statement, and so, but there's also truth to it, right? The thing is that it is not unusual to see systems that are at the very core of very large companies. Like, there's a huge amount of value based on top, and nobody knows how they work.
Right.
and that's and it doesn't have to be like this. The good thing about this whole approach is that the skills are already in the house, and especially now with data science is getting pretty much everywhere. The skills of just going through data they're pretty much pervasive today. So it's not that foreign. It's not that you do not need a super large investment to this. Now, it so happens like this work that we had on moldable development dates now back to 2009. That's when I first started on this thesis. So it kind of went in parallel to the work that happened in data science, but there's a very close resemblance there, and it's absolutely possible, and it's not more expensive. In fact, today, like the way we do it when we work with companies is that they basically, people think, oh, this is a new thing that will cost me some more. In fact, when you're doing this, it costs you less. So you're investing, but the investment all pays off within a very short amount of time. This is because this is what happens when you do not talk. Like, when people don't talk about how they read code, the business does not know like how it spends the single largest amount of the budget. And so, and you know, if you don't talk about something, it's not explicit. If it's not explicit, it's probably never been optimized because like nobody talks about it, right? And so, I mean, even on your show, how many times people have just said, "Oh, okay, just here's an interesting perspective," and when I look at this one, right, lots of things came into, fell into place much better just because I made this problem explicit, right? How many pieces of technologies don't work exactly like that? And that's exactly what happens in a business. So there's a very interesting right now. There's a very interesting business imperative. So there's an economic imperative to invest in this way of thinking. And so what we are doing is we want to put together the we don't have the end of this conversation, but I'm very sure now that we have the beginning of the conversation.
That makes a lot of sense. I mean, tying it back to the environmental comment too. Now it makes a lot more sense. I was going to ask you about the environmentalist moniker, but yeah, I mean, this kind of reminds me of like carbon offsets or something for companies in that sense. Right. Where you're just giving people a lot of time back and removing pollution from the system. So, and pollution, I tend to agree. Like at first, when I read about this, what you're doing, I was kind of like, I don't get it at all. But it makes a lot more sense, I think, when you spend a few minutes thinking about it, because all of us have been there, right? I mean, staring at IDEs for hours and hours and hours trying to decipher the code. And you're right, that's a lot of money spent reading, right? So
there's another thing, right? So there's the money, right? But then there's so there's an economic imperative about this. But then there's another one, is that whenever we ask people, do you love working with legacy systems?
Oh, yeah.
Right? Nobody says yes, right? Nobody says yes. And that's like a terrible thing. Now think about this. Let's put it in perspective. So we went through a major, social disruption over the last year with the pandemic. But we as developers, we could continue producing value, being safe, while everybody else was dramatically impacted.
Right.
Right. That's how privilege looks like. And we earn way more than any other social category in the world, right? And so that's privilege. Now, being in a privileged situation like this and being unhappy for most of the time, something is wrong, right? I mean, we should be smiling all day long. And yet again, like we find ourselves like, why? Like, no. And the reason it is like this, it has nothing to do with the nature of work. It has to do with the way we look at the work. And we can make this like, so for example, if you look at our Twitter feed at Fincom on Twitter, we post there sometimes pictures of bugs. But we look at not how the bug looks like from the outside, but how the bug looks like from the inside. And that gets retweeted. So, and there's this interesting effect there, right? Which is like, nobody wants to look inside the system. In fact, that's like, we don't like it. It's at most we're going to look at the interface and that's it, right? The UX or maybe the API, but that's pretty much it, right? I don't want to get into that system. Like I do everything possible to never ever get into the system. Why? Because the expectation is that it's going to be ugly there. Whereby ugly is that I cannot form a mental model of anything that is happening inside. But what if we could change that? What if problems that are happening inside the software system can even become marketing problems, like marketing tools? And it is not the first time this actually happened. So if you look at something like Intel Inside as a slogan, right? It made something that was a commodity that nobody really cared about into a marketing tool. If you look at what Apple did over the last, 2.5 decades, they started mid-90s if you would open a computer, it would be really ugly. Like if you would open the Dells and the HP of the world at the
I remember
time,
those. Yeah.
those computers would be really, really ugly, right? And then, if you look today, actually started about 2 decades ago, and it got me. No, it started 15 years ago or so. It got me really puzzled. So a company like Apple has these interesting, crazy cult-like, marketing events, right, which takes like hours. All right, and where you have tens of millions of people that tune in voluntarily to watch a 2-hour commercial. It's like crazy, right? And so it's also a huge, it's a huge value, right? It's a huge, huge amount of value. Now, why would a company like that spend a significant amount of time, and by my calculations, they are like into the maybe 10, 20% of the time showing you the inside of a system, given that the company goes to enormous lengths to prevent you from ever seeing the inside of that system directly? Why would they do that? And so until I found this this interesting TED talk that was showing, like, it was a designer, Seymour, and he was talking about how a story of how one person went to a watchmaker and back in the day, and then the watchmaker took the watch apart, and then the customer saw that on the inside of the watch there was an engraving, and then the customer said, why did you put an engraving on the inside of the back, on the inside of the watch, because nobody will see it there. And then the watchmaker said, God will see it. And there's a very interesting perspective there. There's a very interesting correlation between the beauty inside and the value that we can create outside. And we can, those smiles, like every time we don't smile when we look inside a system, we are harming ourselves and we are harming the outcome. And there's a very large stake associated with the kinds of work that we do as developers, because like the whole world is being reshaped based on what we are building right now. And so our kids will only know a world of software. And so that's a significant shift. So that's why I think it's very important for us to be smiling on a regular basis, because unhappy people are unlikely to produce happy solutions. And we need these solutions to be happy.
That's such a good point. I think tech burnout is a real thing too, right? And I think that it's, no, these are good points. It also reminds me too, I think, bring it back to Apple for a second. I think it was the original iMac. Steve Jobs had the engineers sign their names on the inside. Yeah. That was pretty cool. So, but not a lot of people think about quality that way, though, right? I mean, it's because if you look at the incentives to produce beauty, it's more like, well, but how many lines of code have you written today? Or how many pull requests, have you, submitted, and that kind of thing. So I think it also comes down to just, I think, the incentives for developers to really put in their best work and create beautiful things too. So, but, management sometimes doesn't feel the same way. So,
but the thing is that the one thing to note very quickly is that when the time when Apple was doing those kinds of things, it was not obvious, right? They were not. And like the other ones were focused on how quickly can you make another board or whatever. But then it turns out that if you do pay attention to this, you can unearth a dramatic amount of value that otherwise can become a competitive advantage. But here's the thing: not even a company like Apple that probably understands the value of the beauty inside ever shows you the inside of a software system.
Right. That's a good point. I think haven't open source much for one. So that's interesting. We're coming up in time. It's a fascinating conversation. You definitely, the thing I like about talking to you is you just have such a different perspective. And I think a much deeper fundamental perspective than a lot of people I talk to in the tech industry. So it's awesome. So yeah, thanks. For people who want to know more about Fink and Glamourous Toolkit, how would they go about finding that?
Also, Fink is our company is FENK, comes from Feel and Think, fink.com.
Cool.
And Glamourous Toolkit, you can find it at gtoolkit.com, and you can find us on Twitter as well. So Fincom is our handle on Twitter, and my handle is GIRBA Girba.
Awesome. Tudor, fascinating conversation. I'm definitely going to recommend people check out Glamourous Toolkit too. I think I'm sold on the idea. So awesome, man.
Good.
Yeah, cool.
Thank you.
Yeah, have a good one. See you.